I'm Anil Kumar with Unit Test 3, test paper on quadratic functions for you. Now I have 15 questions in this series of test papers, and I'm sure by the end of these 15 questions, you will really appreciate this chapter on quadratic functions. Now, my advice is that when you read the problem, I'd like you to copy it, pause the video, solve it yourself, and then look into my suggestions. That way, you're going to learn a lot. And I'll give you some tips which will help you save time in examination hall and also get right answers in minimum time. Let's start with the very first one, which is finite difference. How can you show that the function shown is quadratic? Find the equation to represent the data. So the data is for x values of -1, 0, 1, 2, and 3, the y values are 5, 2, 5, 14, 29. So you can pause the video now, answer, and then look into my suggestions. Now my suggestion here is, we already know that the function is quadratic, but we need to find a reason for it. Reason from data is always first difference and the second difference. So let's find out the first difference. Now when you are finding first difference, you should note that the x values are arranged in a way so that they are in order. They could be increasing or decreasing, but they should be in particular order. So as you see here, they are increasing by 1, so that suffices the requirement. Now for the y values, we are looking for difference. So first difference is, let me write with delta 1. Delta represents difference, and 1 here is my nomenclature to show you first difference. That means like y2 minus y1, right? So always do y2 minus y1. So that means we are doing 2 minus 5, right? When you do 2 minus 5, what do you get? You get minus 3 in this case. Now here you do 5 minus 2. So we have 5 minus 2, which is plus 3. And then we have 14 minus 5, and that is 9. 29 minus 14, and that gives you 15. So that is the first difference, and we find that the first difference is not really constant. Therefore, it is not linear. Now let's go for the second difference, right? So let me use different ink for second difference. So that was the first difference, right? So the second difference for us is, now we'll again do y2 minus y1. You see that? So we'll do 3 minus minus 3. So we do 3 minus of minus 3, and we get what? 3 plus 3, which is 6. Now in this case, we do 9 minus 3, which is again 6, and then 15 minus 9, right? So we are doing 15 minus 9, which is again 6. So we find that the second difference is constant, and second difference is constant and is equals to 6. Now since the second difference is constant, it is indeed a quadratic function. So we have done the first part, that is, how can you show that the function is quadratic, right? So we say since second difference, right, which is constant and is equals to 6, right, it is a quadratic function, right? Now, the question part 2 is, find the equation to represent the data. Now that is a huge question. Some students can spend about 10 to 15 minutes finding the equation, right? They may start with equation like y equals to ax squared plus bx plus c, and then using 3 points, and the best 3 points are of course -1, 0, and 1, you get 3 different equations, and from those equations you can find a, b, c, and your equation thereby. But this process of elimination and working with simultaneous equations may at times consume a lot of time. Now with this knowledge which you've learned in this chapter about quadratic functions, I'll give you the best way of writing the equation. Now the best way is, of course, here when you see the data, you find that the vertex is at 0, 2, right? Since the values really 2 is the lowest most, and you see that symmetry. Do you see that symmetry? It confirms that this is the lowest most point, And these are the point on the right side of parabola, which is opening upwards. And that is the left side of the vertex, right? So the vertex we can see from here is at 0. The value is 2, and that is a minimum, right? And from minimum, the difference is 3. You can see minus 3. The difference is 3. Is going up. So you have to appreciate how the parabola is. So in this particular question, you can see that your parabola really is kind of like this, where that bottommost point for you is 0, 2, right? And if you move the first step, you go up by 3 units. Do you see that? So the steps in parabola are normally 1, 3, 5, 7, right? So A in this case is 3. So what I'm trying to say is, first you know the vertex is this, and second you know the steps. Steps in this case normally, if the parabola is not stretched or compressed, the steps are 1, 3, 5, 7 and so on. In this case they are times 3. Do you see that? The steps. So the first difference really give us the steps. Do you see that? So the first step is 3, not 1, and the second is 9. Correct? So, and the third is 15. That is 15. So what I'm trying to teach you here is how to relate the data which you have got. These are your steps. When you multiply 3 by 1, you get 3, then 9, then 15. So these are your steps. And I'm sure people really don't get this concept when they do finite difference as the starting of parabola. This should be also the last chapter of quadratic functions, and this sums up everything so beautifully. And that is why this question here, the very first in my list, is probably the best question to be answered. Now you know the steps now. So from here we can write a quadratic function. So we say f of x, or we can write y equals to whatever you feel comfortable with, right? A values normally it will be a times x minus p whole square plus q, right? That is the vertex form. Now in this we know a is positive 3. We are going up by 3 times 1, 3, 5, 7, right? And the vertex is at 0, 2. So p is 0. I'm writing 0 with a purpose so that you understand. Sometimes it could be a different point, right? And the minimum value here is 2 plus 2. That is the minimum value of the parabola, right? And therefore you get your equation, which is 3x squared plus 2. So that is your equation, correct? So we can now write down our answer clear and bold, and that is the equation which represents the data is y equals to 3x squared plus 2, right? I hope you love this process of finding equation from data, and it's going to save a lot of time in a test paper. If you appreciate, do write down your comments. And if you get similar question and you have saved time with this technique, do let me know and let your friends know. Thank you and all the best.